there's a lot of hub discussing and a lot of people participate, is to talk about the CRI next step and also the Docker shim, and which is the only built-in the container runtime for today. So we want to kick out, even we understand there's a lot of production and depend on that one Docker shim today. And a lot of people is doing the transition from the Docker as the Kubernetes, the default and only container runtime to the other container runtime. But we do understand there are many dependency at this moment. But we think about this will take like the half a year to 1 year to finish the whole entire of the transition. So we want to start the discussing. So Dim, do you want to kick out the discussing, start this one? I didn't see the Dim join today. So maybe we can start. So I also invited the Docker folks. Can you from the Docker, can you speak out? Can you introduce yourself to the community? Okay, so.
Hey, Derek, I think that's for you, probably. Maybe he's mute.
Yeah, I'm on here. I can talk a little bit about it.
Welcome.
So I guess you said Dim is not on the call today?
Yeah, I don't see him on the call.
I mean, yeah, I don't have too much to add except for what I said on Slack. That I mean, I have my personal view on it, but I'd really like to get I'd really like to see where the community would like to go with it.
Derek, actually in the past, when we talk about these things, and actually Docker expressed a strong desire to maintain Docker shim and maintain Docker shim related of the container runtime interface conform test, all those kind of things. I'm not sure because we didn't follow up on that one. So is there anything change on that one or any action item and leave there? So we want to talk about more of those things.
Well, I have an action item to discuss this internally to figure out like what we want to do there in terms of investment. I think from the perspective of like where we are today, we haven't had any kind of involvement in that. So I think we need to figure out kind of some owners internally that could own that. I mean, me personally, I'm not really the right person to own that. I have a lot of other stuff that I own, but just since I work on Docker and Containerd, I've kind of found myself in this position of trying to answer the question of what we should do here.
I think Derek, you may be the best people to talk about briefly about from the 1806 or 1809 Docker, the whole stack Docker engine stack. It is built on top of the Containerd. Maybe you want to say something related to the whole stack, how we are going to plan to help the existing Docker user if they want to transition to the Containerd, how we are going to transition to Containerd.
Yeah, so for us, there's kind of an intermediate step that we're working on right now, which is getting Docker to utilize all of the components of Containerd. So historically, Docker has leveraged the runtime components of Containerd, and then we've added this kind of image management snapshotting that's used by CRI Containerd today. So it's not just a matter of like Docker's passing through everything to Containerd today. Really, it's CRI Containerd is doing some image management using Containerd code, and then Docker has its own image management code that's stored in a completely separate place. So it's not just a matter of upgrading Docker to use Containerd and then we can just leverage CRI Containerd as is. We really have to kind of migrate kind of the way Docker is doing storage to the way that Containerd is doing it, and then we can start talking about having the two kind of share kind of a common implementation. So like in terms of like timeline, you mentioned 1806. I think it went back to maybe 1712 when we first introduced Containerd 1.0. But it's not going to be until a release this year where we're fully leveraging the Containerd backend, so that when you're polling and doing all the operations in Docker, it's actually all that stuff would be visible within Containerd. That's kind of the first step, and then after that, like the operations that you would do with CRI Containerd would have kind of the same back-end effect as stuff that you do within Docker.
Yes.
That's just not where it is today.
I just want to mention that the reason I mentioned 1806 is just because that was on top of the CI Containerd. So basically, you are going to, even we migrate to the, for the user, migrate to the Containerd using Containerd CI to communicate, do all the thing, you could still install entire the Docker stack. You still could using Docker image feature, building feature, compose feature, and to do the work. The reason we made the decision to merging those kind of things together, there's the performance concern, there's the simplification, installation concern. Another one concern it is because we think about all the use cases. Because you don't want to have the CI Containerd, and then you also have to install another separate Docker for the image building. So we have to think about those cases. That's the reason I mentioned that 1806. Because at least to me, that's the version start to have the everything's together.
Yeah, so I mean, everything should be there where you could, like if you have 1806, you have Containerd there and available to use if you enable the CRI plugin. But it's, well, I think as was pointed out, it's not turned on by default today. We would like to have that turned on so that if you have Docker installed, you could try the CRI Containerd plugin.
Mm. There's any question from the community have the concern to using the Containerd or CI Containerd and also transition from the Docker to the Containerd?
So Don, this is Derek, the other Derek. I guess I don't know what we're actually going to get to closure on the call right now on. Like it seems like we have to identify the prereqs needed, and then we ultimately have to ask ourselves like, did we want the kubelet to ship with any embedded CRI implementation or not? And so if we get to a state where you say we're going to remove the Docker shim, then ultimately you have SIG cluster lifecycle asking, well, which one should we run? Which ones do we test? And obviously there's a variety of implementations that are available for people to look at. So is it the right use of our time right now to explore this much deeper if we don't yet know all the gaps one would need to actually eliminate an in-tree CRI implementation? Because that's basically the effective goal that's being described versus just document what we think the prereqs are that need to be done. And so getting the CRI to a state that we are all happy with seems like prereq 1. Getting the Windows folks satisfied seems like prereq 2. And that still seems like we're a long way off before we would actually be able to get to a spot where we'd say, does the kubelet ship with a out-of-the-box shim or not?
I think that, you are totally right. I don't think we can take any action. I would just want to kick out since the community raised this voice, and also many people really looks like found a thread. Many people actually have a lot of confusing. And also you are right. Even we want to deprecate, if we eventually we don't want this built-in sham to talk about the CI, and then we need to talk about okay, what it is a replacement for our testing, what it is for our E2E test, what it is. But I think I also want to take this chance to repeat SIG Node decision. When we first started CLI, we've been repeating that decision for many times. We think about which container runtime we define the common API, and then which real container runtime implementation is running, we actually give to the image provider and also vendor, the Kubernetes vendor or image vendor, up to them to decide it. So I will also want to take this chance to repeat that one. So like the same thing, we have the containerd, and we also have the cryo, and a different image, different operating system distro they want to use in different container runtime. So we provide, as the SIG Node, we provide the CLI conform test to ensure all those is pass Kubernetes requirement, Kubernetes requirement, and on the node, Kubernetes node requirement. And then, but then each vendor or each container runtime vendor and run those tests, include performance, functionality, correctness, all those kind of things. And for each release, they update those things. So it is their responsibility. At least I want to take this chance to repeat that. For it's their job to provide for each release to provide what is version they support and also what it is compatible with the given Kubernetes release.
So I'd like to speak to that particular requirement. I think you're right that it is a valid requirement that the container runtimes will validate, run the end-to-end tests. But at the same time, once we move Docker shim into its own tree or separate it completely, at that point, Kubernetes will have no choice but to pick one or two or three, and then on each PR that's pushed, right, run the end-to-end tests with one of these cry shim enabled, right, if not all three of them, which will make running each of your tests longer. And then the requirement to make these things work is a shared requirement between the groups, both containerd, cryo, right, and maybe the Docker shim one group that would be new with the Kubernetes team. I don't think this can be only the container runtimes own the testing of end-to-end tests for Kubernetes. I don't think we have the manpower in the container runtimes to do that. We've had a number of situations where Kubernetes has put, because they had to, they put patches in kubelet and that are directly to Docker. And we're still finding those. I know Yuju's got a lot of work going on to try to pull those out, but we need to do that so that we can finalize this cry API, right? So that we could even consider doing, ripping the shim out.
Yes, that's for sure. The reason we want to discuss is just want the community knows there's a lot of the hidden requests. It's not just simple. We can get it. We already have some people already have the container in production, and then some vendor already have the cloud in production. So, but for community, we still carry the burden. And like Docker shim, and because there's a lot of the production dependent, and also there's a CLI dependency, like the new feature, like the Windows container support today, still depend on the Docker. So there's many things that we just want everyone understand on the same page, so we can start to talk about. Yes, Patrick.
Right, yeah. And we've got to think about our customers, because I'm very concerned about each of the runtimes making independent decisions with regard to things like idle timeouts that came up, the other day. We need to have a common decision at the cry entry point. We can't just make some of these decisions, otherwise you'll end up with the pods are going to work differently, have to be configured completely differently, which is what happened with networking, right? I don't want to see that happen to the runtimes if we can get away with not doing it that way. I'd prefer to see cry move forward faster, let's put it that way, the API, than just doing private fixes all around in the different runtimes.
I will need to, but Patrick, do you have anything to add? And then I think you want to add something related to the container runtime interface.
Yeah, I had two things I wanted to mention. So one of them is when it comes to multiple OS and multiple platform support, I think moving to the Cry API and getting things iterating faster there is very, very important. In the case of Windows in particular, we're already being limited by the Docker shim limitation that's there because the containerd code that's there today already supports some of the things that users are asking us to implement as runtime class, but we can't do it through the Docker API. And so from a SIG Windows standpoint, you're going to see us accelerating an effort to move to Cry Containerd as fast as we can so that we can unlock some of those features. And I noticed like later in the agenda today, there's some questions around things like how to schedule cores and do gang scheduling with hyper-threading. I believe those are all things that need to be represented cleanly in the CRI. And as long as we have Docker shim in the code base, I believe that would actually prevent us from being able to implement that correctly in CRI. So I think this is the right thing to do. And I just wanted to mention that from a Windows standpoint, we want to move to Cry Containerd as fast as we can to unlock those other features and get closer to the parity that our customers want.
Don, I think in the past you and I have had this conversation around what to do with respect to container runtime choice and how long you keep code in the tree. And I think you and I had always said like this is a big impact for our community beyond what our own particular service providers do. And I still feel like this is a big impact. And so I still think we're looking at like a minimum year until anything actually is done here. And so, so even Patrick, to your point, like Windows containers and GA, like if you go GA and you still depend on Docker shim, like I feel like we need to set a clock, and that clock is still probably a year. And so, so I guess I'm wondering what is the right time to like start that clock? Like, do we start that clock once all the dependencies have been met? Or do we start a clock and that forces a community to actually make the changes that it needs to make? Because I could see us going in one of two ways where like we say we're going to make a ton of changes, but then all of us are distracted by our own needs or requirements, and this never bubbles to the top. And then maybe that's fine too. Or we say we're going to like establish a goal, and then we're going to make it a priority to get something done. But I have a feeling that like we're still discussing like 4 releases a year. I agree with Mike that like we can't just leave users in jeopardy. So
Derek, I totally agree with you. The reason I think we could discuss this week, and last week actually we postponed to this week because many people we didn't pre-announced, so not many people here. The reason I want more people understand the complexity behind this one, and so then we could in the future we could make the decision. So we could document our decision if we could, not really say what we are going to do, and it is just when should we start this clock now, or we actually punt and then decided when we revisit this decision. So something like that. So then we can always reference people to look at our meeting notes and say there's the SIG Node decision and we made, and we want to reopen this topic maybe like a quarter later or 2 quarters later. So something like that. And meanwhile, what kind of things, next action item we wanted to do? If we agree that's this destination and that's the ultimate goal, and if today we could agree or we could not agree, we put there. Because every time, I think once in a while, this kind of problem will raise in the community. And theoretically, it's really wonderful. It's best idea, so simplify our code a lot. But always kind of we have to people put into and explain. So we have the community way to document and to put that in some way.
The only awkward part to me is like, if a year from now, the list of like certified Kubernetes offerings in the world, they're all doing something different than what we are defaulting to in the community. And that would be the only awkward state I'd see. I don't know if we've actually reached that state. Like I have not kept abreast of what every other vendor is doing. So, but either way, I still think we're looking at a year timeline. And so it's good that we had this conversation.
Derek, I agree with the timeline. I think it's at least a year from now. But one thing is, I think, yeah, when should we actually kick off this timer is going to be a problem. Even if we do nothing, given that everyone is pretty busy with other projects, even if we do nothing, we have to make a decision about whether we can start adding features that Docker does not support, Docker Shim does not support.
Yes.
And that would be important for actually evolving the CRI and also support more like bottom class and other things. So if everyone's okay with going forward that Docker Shim will not support some of the new features, then yeah, that would be one decision to make. But whether we can actually deprecate all the existing features in Docker Shim, that's another problem. And that's something that's going to break users. So I think for that to actually happen, we need to like deprecate and wait for at least multiple releases or a year.
Yeah.
And so I just want to clarify one thing. So if we're saying a clock of around a year for deprecating Docker Shim, should we move it to CRI, or if we're communicating deprecation early enough, should we just delete the code? I mean, I'm just wondering, if this is a 3-4 release journey, are we going to spend a year getting to an interim part where CRI Docker Shim has lesser functionality but still lives on, or do we just say let's cut it if we're not going to support new functionality on it? I think that's something that would be important for SIG Node to weigh on and say, like, is Docker Shim going to be supported for multiple releases in a deprecated state so people can migrate off with reduced functionality, or do we just draw a hard line and cut it? Like, that's what I want to know.
I think we need a deprecation period. I don't think we can get around that.
But that's just a few releases.
And also, Patrick, we didn't make any decision. I think the 1 year is at least the 1 year that people talk about. So we haven't made any decision. We just want everyone express their concern and why they want to do that or why they don't want to do that, and all the complexity.
You want to make sure you got all the blockers so that we can start the clock to the first deprecation, right?
Okay.
Yes.
Yes.
And like to that point, like a few releases for deprecation is about 9 months anyway, so it's not that different.
Not really too far away from that. And going back to what Derek said, I think we still need someone to scope out how this will impact users and what needs to be deprecated. So even getting that to start and see like deprecating individual things would take how long, that's a start, but that's not the start of the timer.
And also we need maybe along, or maybe we need to decide it, clearly decided, is this one, it is also engaged with the CRI API, promote from the alpha to the beta, or it's not engaged. And also we need, so for today's CRI, also because to support all the customer, we also have a lot of legacy there. Like for the login, for the execute, a lot of things, actually, we do have the legacy support there. And when we was designing those kind of things, we did talk about. And so because we want a smooth transition, and then we supported those legacy implementation, but we do plan to deprecate. Are we still thinking about those should be deprecated, move, and we have the common way to do this logging handling? Those kind of things open discussing, and we need to review all the CRI today and to come out, okay, is the way to promote that to beta. The problem is there's a legacy region and we want to deprecate, and in today's CRI interface, there also have the new support, like the Windows, and also just in general support the secure pod, all those kind of CRI things, and it is evolving and moving. So we should just treat them as the additional feature to the CRI, or we want to address majority of those problems and promote the CRI to the next level. That's all we could discuss at right now. We almost passed the half hour. So Patrick, do you want to say? I thought you raised the hand earlier.
Oh, I just put the stuff in the chat, but I think that, based on what Mike was saying, everything, we should communicate this as a SIG Node roadmap and get feedback on it. and show how it lines up with basically getting CRI stable, because we're still changing it a lot. We still need to graduate runtime class to GA, and then basically set what that timeline is. And so I think just getting all of that clearly communicated is what I see as the next step here.
Yes.
And whether or not we have a Docker shim CRI or not sort of would fall based, I think that would decide itself based on the timeline once we can close on what's reasonable.
Okay. Derek?
Yeah, I'm just thinking about other, like I know we discussed runtime class. I know in the past we've discussed C groups V2. I know that'll be like an interest of mine as the year goes on. And I could see some of these things being challenging to keep going forward in Docker shim. What's not clear to me is like who will act as the advocate for when we know that this is the right thing to do. And so, and I still feel like many of the individual members within the community who have made a transition are not going to be incentivized to spend time to try to make a change. And so, other than if they're going to make a PR update and get frustrated that they have to fix something in tree or not. So, but overall, I still think, like I said earlier, this is a very long discussion and we should just get written up. And I don't know who is wanting to jump up as the owner for it. And
I noticed that Harry didn't join today's call. Harry from the community, from the emails, right? He volunteered to initiate a CAP and carry the most of discussing. So maybe we can start from there.
I think that'd be perfect, right? Like I actually, to me, it's not a good look if someone from Red Hat is doing this, and I don't know if it's a good look for someone from Google to be doing this versus someone from the community to act as that voice, right? Because I know in each of our cases, our companies have made default container runtime choices that we need a voice from the community that represents the existing in tree support.
Okay. So Harry, I think that Harry could work together with some other folks from the different company and to start that pipe so we can come back from that one. So maybe we can come back this topic after the CAP send out to the community and then 1 month later. Is that okay? So next step, it is the CAP. And I will loop the Harry. I will send the email, and also we took the meeting notes and we record today's meeting about this topic. I will send those things to Harry, and hopefully he can from the meeting notes and also record to get all the opinion, and then start his CAP, and then we can share our opinion on his CAP, and then we come back after CAP sent to the community 1 month later.
Yeah, that sounds perfect to me.
Okay, thank you everyone to participate this one. So let's move to next topic and overhead discussing. Last time we also postponed because the involved party is didn't attend. That's right.
Eric, are you on the call?
Eric is on the call. I think
yeah, I'll let Eric introduce
Okay.
himself.
I'm sharing my screen. Can you guys confirm if you can see it? And if you don't see my email, but you see a presentation?
Yeah, we see it here.
Okay, great. So Tim had started the discussion mid last year about basically pod overheads. And since then, there's been a lot more forward progress as far as defining runtime class. And I wanted to just spend a couple minutes quickly to give an overview of what we're proposing here and get feedback. So basically today, if you go ahead and define the constraints as far as limits and requests for different CPU and memory for a container, and all the containers in your pod, you could effectively have a pod C group, which is just the sum of the containers. And when a runtime comes in, it should be using the parent C group that is created. In this case, just quickly look at the runtime spec. It's pretty clear that if a C group path, in this case, it would be kube pod which is created by kubelet, is provided as a runtime, I should be working inside of this pod. So if someone were to create one and use a sandbox runtime, let's say Kata containers, for example, and just have maybe one container in there that's maybe only constrained down to, let's say, 50 megabytes. If I were to use that, I'm supposed to use it, the spec says it, you provided it, we would get in out of memory. We wouldn't be able to effectively launch a hypervisor in such a small, constrained pod C group. So this is just kind of one example of the problem that exists today. On top of that, we're also not really able to get effective scheduling and effective resource quota management by kubelet or for the node itself, because we're not taking into account the overhead associated with a runtime. So currently, with no sandboxes, the read overhead is very, very minimal. And, the allocatable pool has, the system available memory on the system. And then you take away just this kind of carved out overheads around system and kubelet. And that's used enough just to kind of take these into account. And the actual paused container, in a run C type of scenario is negligible enough. And this is kind of how it's managed. As soon as you start utilizing runtime class to use alternative runtimes, whether it be gvisor or a Firecracker integration or Kata containers, the overhead is not negligible, and you would need to be able to take this into account. And if you were to look at resource quotas per user or just like accurate scheduling itself, this should really be taken into account. Otherwise, the current workaround is just carve out a lot more system memory is reserved, and it's not even close to heuristic, and it's very, you'd have to be very conservative to make this work. So this is far from non-ideal, I would say. So really, the summary of what Tim started and kind of refining here for the proposal is to introduce in the pod spec an overhead field, which would be the same as kind of the resource requests field that you would have associated with a container. But this would be dedicated just to the overhead associated with running a pod. This would be runtime class specific. So in the case, for different handlers, today, the runtime class is defined just as a key value pair of a string, and then the CRI may have an implementer. What I would suggest is that we augment that to actually include per runtime class defined, the overhead associated with it, both in a limit and a requests for that, since it can have a bit of a range depending on the workload. With that introduced, with it being available in the pod spec, having this available in the CRD, let's say today, I would then suggest that you would have a runtime controller, an admission controller that would mutate and would see if a runtime class is defined for this pod. Go ahead and implement, write the pod overhead value itself. That's the high level. Looking at it closer, again, pod spec, added an overhead field. I wouldn't expect anybody to have to manually go in and set this. Again, this should be done through something like an admission controller utilizing a runtime class. Whether they can write it or not, I originally was suggesting just only overwrite and use what's provided by the runtime class through the admission controller. If we could kind of get into whether it should be the greater of if there was a pre-value or not, but that's my suggestion. For the runtime class, add the 4 fields basically for CPU and for memory, both the requests and the limits. And again, this is what would be used by the controller to actually update the pod spec. And then add a mutating admission controller. I think depending whether runtime class is still a CRD or if it's a core type, maybe some of this will change as far as whether it should be a webhook or built-in or anything else. But essentially, this is a very, very simple controller that would just go in and, where applicable, inject the actual pod overhead. And that's about it. I do have the original RFC document that's in the Google Doc where it has a little bit more detail, and you can see some of the conversation based on that.
So I remember, I think it was Tim who presented this last year, and this is Derek, and I still feel like this is really complicated. And, you know, we've had some time, and I have less experience with using runtime class, and so I don't want to like discourage the reasons you laid out for why it's needed. I guess I'm still like wondering why we don't just do pod level resource requirements and like ignore this resource overhead thing altogether. I forget, did resource overhead actually tie into quality of service or not? And like if I'm not running with a runtime class, the stuff you enumerated here, like memory back volume still will charge back to the pod C group. So like you have overhead leakage just in the normal course of the application, running application. So
Are you suggesting that, so rather than like a overhead on the pod spec, we would just have resource requirements?
At a pod level, yes.
So then the runtime controller would basically take the sum of what the runtime class was requesting and all of the containers and set that?
Yeah, I mean, basically my experience with Kubernetes these days is like, people don't know how to size anything, right? Like, they just don't. And we do a lot today to try to size individual containers correctly, but like, that's largely a consequence of us never having a pod sandbox, like C group bounding box in the beginning. And like, if we had resource requirements at the pod level, like, I just think the whole world would be simpler for people. They're only like, how much do you want to give to this pod? You map it to a VM type mindset in your head. It would be the power user that would separate at the container level.
I'm not sure if we have the beginning with the pod level. I used to think about that way. I was trying to pro that way, but recently a lot of discussion sidecar container, and then they talk about like the separate release channel for the sidecar container, and they may change implementation version by version, release by release. I was kind of thinking about, oh, thank God we don't have to start from pod level. C group initially, we start from container level, then and the pod level, we still could do the aggregate of the limit. So aggregate on the pod, the overhead, the pod, all the container together.
Of course, I see that both are very valid and would be useful. I could see that having unconstrained containers and just constraining the pod, where you can essentially say, you kids can do what you want as long as you sit in the sandbox, makes a lot of sense. I've heard different people kind of ask and assume that this was in the pod spec already when it's obviously not. So I kind of, when I was initially looking at this proposal, that was something that I had thought of, that maybe it makes sense to just say these are the requests and limits, the resource requirements for the pod itself, instead of just defining the overhead. In my mind, I kind of want both effectively, whether implicit or explicit.
Okay, so can I walk through the user experience on that real quick? So let's say you wanted to do a container with a limit of 100 megs, but you wanted to leave room for a sidecar. Then in that case, you would say the pod has a request of 200 megs and a limit of 200 megs. And so now there's this delta of 100 megs that I could use for scheduling that sidecar. Is that kind of what you're saying?
Yes. I mean, today you effectively have to size both. Otherwise, you have no way of like getting that slush within the pod boundary.
Okay. And so now the second use case is if we're looking at the overhead due to a hypervisor for the case of like Kata or Hyper-V, then are we suggesting that in order to make room for this overhead, if we were to do it using the pod spec, then we would still need a runtime admission controller that says, hey, your runtime class is using a hypervisor, so add the hypervisor overhead to the pod request and limit. Is that how you would see that implemented if you went that route?
That's what I was proposing here.
Yeah.
Yeah, but in this case, we're saying it's a different field. And then Derek was saying, I think the different field is too complex. And so whether it's a different field or not, I think the runtime controller is still needed. I
think the runtime controller is still needed. I've lived now through like 4 years of explaining resource requirement setting, and I don't think we've done the perfect job of making it easy for users to think about. And I'm more and more convinced that like people just want to think about their pod, and it's the power user that thinks at the container level, and even then they think wrong. And having something at the pod boundary first, I just think is so much easier and solves a lot of problems. And I still feel like the runtime controller, I don't want to, I see that you want to increment that. I just think having more fields for resource requirements is just a lot of headache.
Yeah, but that wouldn't be the developer at that point. This would be, you know, I would see that whoever's defining the runtime class, or maybe the administrator of the cluster would define this. It's not like I have my workload and I want to take this into account. So at least
it all starts with a bad example, right? Someone on the internet like cats out pod that was running, and they see a resource requirement overhead value of X, and they copy and paste that into their new cluster, right? Like, and suddenly bad practices have permeated all throughout the internet. And like, it's a thought, like, I just don't think the user should have to think about, like, and so I don't feel like it should appear on a pod spec.
Should it be
it's a system overhead. It's not something.
Yeah, I wouldn't expect it. Can you define user in this case? Is it someone writing the workload or someone operating?
Someone writing the pod template that appears in a workload controller.
And that's why I was saying that they shouldn't ever have to write it. It should come. That's why the admission controller would be there. So that way, if you have a runtime class defined, whether that was from an admission controller or whether someone decided that this is what they saw on the internet and want to do, they would just write that, and the admission controller would go through and augment the pod spec.
I think the point that was being made is, if it is part of the pod spec, no matter how many admission controllers you throw at it, somebody on a popular Stack Overflow post is going to stick it in their pod spec. Millions of people will copy it, and the next thing you know, it's everywhere, independent of whatever your admission controller is trying to do.
Right, and what I was suggesting is that you can write your YAML and you can apply it, but the API server would overwrite it. Or you could pick the bigger of the two. You know, if you say you love overhead and want to eat all your CPUs, go for it. But this is what the administrator said this runtime class costs from an overhead.
Actually, Derek, I understand your concern about the usability. So user bad behavior set this overhead. But I just realized actually if we introduce pod level of the resource request and the limit, the user also could set that one. And they don't properly set their container level of the resource request. They think about this site, and some user maybe bad behavior, and so some people power user maybe cited because they believe their container can share their resource because they have the different time of the burst. And some user maybe really carefully think about they consider of the aggregate of the container resource requirement plus the overhead. So it's the mixed behavior. So how are we going to distinguish that one?
Yeah, but like a vertical pod autoscaler would be so much simpler if it just resized pod boundaries and like you didn't have to resize at container boundaries. Like the VPA in-place resource resizing discussion, and like I still think is complicated because you have to figure out which, do you resize the container first and then you resize the pod sandbox or vice versa? And I fully recognize that I am not as integrated thus far in the runtime class alpha to beta work that everyone's been doing here, and I don't want to discourage it. I really think resource requirements generally, when they appear on pod specs, introduce confusion everywhere. And I don't think the overhead concept means anything to anyone other than a container runtime implementer, and not something an end user even knows about or thinks about.
Yes, I also agree with that one. So this is a more exposed internal implementation to the end user. This API definitely, and the pod level is not, but as you can see, the user could be misuse that one and cause problem. Also,
I think that we've got sort of two things here. One is exposing overhead is exposing inside baseball to top-level user API, so it seems like an abstraction leak. from the system that users shouldn't have to deal with. But on the flip side, there is some benefit in a completely different context of having resources at pod level, because it sort of matches the expectation from other kinds of things like network context that you typically see for pods.
Just to throw out a couple other alternatives. Possibly this is something that we could put into status, although I don't know what it would be like to write something to status on create. If that's okay.
I don't think that.
No.
But constraining the C group is still going to be a problem. I can't take a kubelet created C group that doesn't give me space to run. And I think being able to enforce it.
Yeah, I was just talking about API wise.
Okay. Okay.
I mean, another option is pull the overhead from the run, just to have it be something that comes from the runtime class. And so the kubelet would grab that from the runtime class spec. The scheduler would need to look at the runtime class.
Tim, I don't want to be, I feel like a wet blanket on this because I know we litigated this some last year and even I went back and forth on it a lot. I don't know, as someone who's not as deeply invested in working on runtime class, like I don't want to be the one that's stopping you guys from doing what you guys obviously see as the right thing to do for your use case, but it just feels complicated. But if it's the right thing, it's the right thing. I just want to really think hard about it.
I agree.
I mean, is there like a more transparent way for the kubelet to find out about the required overhead and just reject pods that won't fit?
Then the scheduler has to do it too.
Yeah,
and
it does.
And resource quota.
And it feels like something that you want to be kind of statically tied to the pod at that point as well.
Yeah.
I feel like if it's not in the pod spec, we'll have to change a few different places than to become aware of it. The pod spec, I agree it's awkward if we have something in there and say, oh, just don't touch this. I appreciate that. Even if the runtime controller will just blast it away, it doesn't make sense from an end user. But as far as an easy from an implementation standpoint, it's clear exactly what needs to be done. It is at the pod level. But yeah.
Was this field looking to be added as a part of moving runtime class to beta, or was it something you'd keep in alpha for a while?
Yeah, I think we would introduce this as a separate feature. So yeah, we're probably talking like 1:15 timeframe.
That's what I was hoping for, because again, without this, I don't see how you can effectively run a deployment with Kata.
Yeah.
You can do it, but not effectively.
Will this confuse the VPA?
I don't think this will confuse the VPA. Yeah, I don't think so. This shouldn't confuse the VPA, but definitely once you enable VPA, I think that admin controller, runtime controller need to understand.
Like if I run OC ADM, or not OC, if I run kube control top on pods, like that will include the overhead attributed to my runtime selection?
It should if it scrapes the C group, which is what it'll do. It won't work today, just because we can't operate in the pod C group.
Yeah. Today, the kube control top is actually an aggregation of container level metrics.
Yeah.
So it doesn't work today, but someday. Coming soon.
Well, but the sum of memory that you see in kube control top does not line up with node allocatable because there's other, we already have reserves there today. So like, I don't think that's necessarily related.
So basically, if all the empty like memory backtracking that's lost on container restarts, that's not capturing kube control top, David, for what you're saying it's doing.
Yeah.
I'm not like super familiar with the bug you're talking about.
Like anyone who writes to a memory backed volume and the container restarts, like the charge goes back to the pod.
You're right. Yeah. So that is long.
Okay.
In kube control top.
So let's just carry more the discussion on the cap. And I think at least this is definitely enhancement for our overall resource management. And we have on the node resource management, we do have a lot of missing accounting resource, which will be eventually cause the resource starvation on our node and cause instability on the node. Right? So that's why this is definitely, it is no matter it is the pod resource level of the resource requirement and request and limit, or it is the overhead, it is enhancement.
I think the only other option, Don, I think we discussed this last year, and maybe I'll ask it again and people can tell me why it would be bad, would be like, it's a fixed overhead per pod, I thought, right? And so if you had configured a node that says I'm running Sandbox and you treated that as a counted resource, then like the node could advertise the number of total things it could support, right? And
that's
then
what we can do today. It's just not efficient at all, right?
And not just efficient. That's actually also have another part of even more complexity. Because today in the node, we have the reserve for the system daemons and also Kubernetes daemons. So then we basically have the concept based on that one, machine capacity and subtract of the other reserve. Then we have the kube pods concept. That's the top level of the C group. So based on this kind of things, you have the new pod coming, you increase of that C group and the top level C group. If you have the less the pod there, then you may have to reduce. Are we going to reduce those kind of things or keep that is big? So that's kind of the complexity. Then another round of complexity we need to address. I feel like that we are basically push the problem from the one pieces to another pieces, and but then give the more like the at the node level instead like the local region level like. And another thing, people also, if I remember correctly, last time we talked about, there's in the community, people ask for if they want to have the node, have the regular node, also have if like the runtime class and support actually regular node and also secure container. For example, gvisor. Gvisor node could be supported regular Linux, native Linux container, also could have to support the gvisor. In that cases, the runtime actually is different, overhead is different for different parts. How I'm going to address that problem?
it just feels like we're trying to solve like the final state rather than incremental steps. And I understand that you wanted to have some pods and VMs and some not on the same node. Personally, I think that's like phase 2 of something and not phase 1 of something, and I would have been more incremental on it rather than trying to support heterogeneous. But
totally agree. I'm more concerned to solve today's problem, resource accounting problem on the node, because even we have the POS container, we still didn't charge it to properly, and so that's it's the hidden resource usage and sometimes cause problems, resource starvation issue.
Another example is the run C memory limit that we hit with the recent patch.
Yes, actually so Derek or maybe like the Nanta want to talk about a little more. I do want to take last 2 minutes mention this one because that will affect production everywhere. So,
okay, yeah, I will put the link on the meeting notes soon. But basically, after the run C CVE fix, we observed a memory spike during run C start. So if you have a pod with very small memory limit, say 5 mega or 10 mega, it's possible that your pod cannot run anymore because of the memory spike will exceed the memory limit and it will get room killed. Yeah, so that's the issue. And we're working with the OCI community to fix this. And here currently there are several proposals and they are working on that. Yeah.
Yeah.
And
If we couldn't work out that one, then I think there's a Kubernetes have to change. Kubernetes by default, each work node, by default, minimum of the memory request is the 4 meg. No matter how you don't specify, I give you 4 meg. And that might have to change to the 10 meg or 15 meg. So we are still working on that one, identify those things. And internal, we did some measurement and we found those problems.
Yeah, and if this is not fixed, hopefully it will be fixed. But if this is not fixed, it means that we will have a special model that you will have a fixed memory spec at the beginning, but actually your workload may use much lesser memory. And this is only for the Wednesday issue, and for other, maybe for sandbox or scenario or for other use case, there may also be some memory usage pattern like this. You have a spec and you want to tolerate that. And we currently in Kubernetes resource management model, we don't have a way to tolerate it.
So we are going to, I think that Nantal, could you please send an email to the community, the Kubernetes SIG Node community? And because this is actually, we do have several working item proposed, and I will only address the 2, and also I personally want to take the last 2 minutes to talk about this. So and the rest of things we kind of have to postpone to next week. So there's some like the resource management topic related to the NUMA awareness and the typology awareness, all those kind of things that have to postpone to the next week. Any other? Okay, so thank you everyone for attending today's SIG Node, and see you guys next week. Have a wonderful week. Thank you.
Thank you.
Thanks, everyone.